In this video, I'm going to be covering grade 11 equations. Now, grade 11 equations and grade 12 equations are basically the same. So that means that if you can do grade 11 equations, you can do grade 12 equations too. I'm going to start with my notes like I like to start with. Remember, please take down notes while you're watching the video. The more you do, the better you'll be. Plus, practice makes perfect. Perfect practice makes perfect, but practice makes perfect too. So we're going to start with our notes. So we have different types of equations. So we have linear equations, quadratic equations, exponential equations, surd equations, and simultaneous equations. And that's what we're going to do in this video now. Remember, how do you identify a linear equation? A linear equation has the degree being 1. You solve it by isolating the variable and you'll get one answer. A linear equation results in a linear graph. Then we have quadratic equations. And quadratic equations, you can identify that it's a quadratic equation because the degree of the equation is a 2. Quadratic equation has 2 answers. How do we solve a quadratic equation? We have 3 ways to solve a quadratic equation. We can either factorize, or we can use the quadratic formula, or we can complete the square, depending on what the question asks. And it's going to give us a quadratic graph or a parabola. An exponential graph, how do we identify it? The degree is the variable. So the variable is the exponents. An exponential equation results in an exponential graph. How do we solve an exponential equation? We make the bases the same. Drop the bases and equate the exponents. Then we have our surd equation. Now a surd equation needs, a surd in it. So that's our square root sign. We have to start by isolating our surd. That's the first step. Isolate your surd. Then you're going to solve. Don't forget your middle term when you're squaring out a binomial. And then the most important thing with a surd equation is in your final step, you have to check your answer. So you have to check your answer and eliminate whichever answer doesn't fulfill the equation. Then our last type of equation that we're going to be talking about now is our simultaneous equations. Now, simultaneous equations is when we have 2 variables that we need to get the answer for. So we need to solve them simultaneously at the same time. So what we're going to do is we're going to isolate one of the variables. So you can either isolate the x or the y. I mean, it could be an a or a b. It could be anything. So we first isolate a variable. Now, what does it mean to isolate a variable? It means to get it alone and positive. Okay, so the variable has to be alone, the variable has to be positive. Then you're going to substitute it into your next equation and solve. Remember, we could use substitution, we could use elimination, whichever one you prefer, that's the one that you need to perfect. Let's get straight in. Question 1 says solve for x in each of the following. So the first question is 3x squared minus 5x minus 1 equals 0. And it says leave your answer correct to 2 decimal places. So that tells me that I'm going to be using the quadratic formula. If I look at my equation, the first thing I'm going to do is I'm going to start by listing my a, my b, and my c values. So a is 3. B is negative 5 and C is negative 1. Now I'm going to write out my quadratic formula. So x is equal to negative b plus minus the square root of b squared minus 4ac divided by 2a. So that's my formula. Now I'm just going to substitute in. So x is equal to negative, b is negative 5, plus minus the square root of b squared. So I have negative 5 squared minus 4 times a is 3, times c, which is negative 1. And that is all over 2 times a is 3. So now what we're going to do is we're just going to simplify this and we're just going to get rid of any of our unnecessary brackets. So we have x equal to positive 5 plus minus the square root of, when I put that discriminant into my calculator, minus 5 squared minus 4 times 3 times negative 1, I get an answer of 37. And that is all over 2 times 3, which is 6. Now what you're going to do is you're going to type that into your calculator, but you're going to type it with a plus sign, then you're going to get an answer. Then you're just going to push your back arrow. So you push your back arrow, back arrow, back arrow until you get back to that plus sign, and then you're going to change it to a minus sign and you're going to get your second answer. Therefore, x is equal to 1.85 or x is equal to negative 0.18. The next question says solve for x given that x squared minus 6x plus 8 equals 0. For this one, we just have a normal trinomial, so we're just going to factorize it. So we look at our third term. Our third term is positive 8. So that tells me two things. It tells me that the signs are going to be the same. What are the signs going to be? They are both going to be the middle term sign, which is negative. So both the signs are going to be negative. And I'm adding the factors of 8 to give me my 6. What are the factors of 8? 1 and 8. And 2 and 4. Which of those factors when added together give me 6? That's 2 and 4. So I'm going to have 2 brackets equal to 0. The signs are going to be the same. Both the signs are going to be negative. X squared factorized becomes x and x. Then I take the factors I've just picked of 2 and 4. But I'm solving for x. So therefore, x is equal to 2 or x is equal to 4. The next question is solving for x if 4x minus 2x squared is less than 0. Now I have an inequality, and how I'm going to solve an inequality is I'm going to work it similarly to an equality, all right? Except I'm not going to change the inequality sign into an equal sign because that's just going to get a bit confusing. Some people use a sketch, some people use a table, some people don't use anything. I'm going to be using a sketch. Now, if I have a quadratic inequality, I'm going to do the same thing I would do for a quadratic equation. And that is take everything to one side, make it equal to 0, then factorize fully. Except obviously I'm not going to make it equal to 0. So I'm going to take everything to one side and I'm going to make sure that there's a 0 on the other side. And then I'm going to factorize fully. After I factorize fully, I'm not going to make each factor equal to 0. I'm going to get my CVs or my critical values. Everything is already on the one side and there's a 0 on the other side. So I'm just going to make this easier, switch my negative 2x squared and my positive 4x around just to put it into standard form. Now I'm going to factorize, so I can see that there's a 2x common, but I'm not just going to take out a 2x, I'm going to take out a negative 2 because I don't want that x squared to be negative. So now I'm going to take out negative 2x. When I take negative 2x out of negative 2x squared, I'm left with x. When I take negative 2x out of positive 4x, I'm left with negative 2 being less than 0. So now what I'm going to do is I am going to divide by negative 1 because I want to get rid of this negative here. All I need to remember is that when I divide by a negative or multiply by a negative, my inequality sign will flip around. So my left-hand side divided by negative 1 will give me 2x into x minus 2. And now the inequality sign will flip around because I have divided by that negative. So it was facing that direction. Now it's going to face the other direction. And 0 divided by negative 1 is still 0. All right, if this was an equation, I would now say that 2x equals 0 or x minus 2 equals 0, and then I'd be able to solve for x on both sides. Now I'm going to do the same process, except I'm not going to work it as an equation, and I'm not going to say x equals. I'm going to get my CVs or my critical values. And those critical values are determined the same way. So I would say, what would my critical value for this 2x be? Well, it would be 0. And what would my critical value over here be? Because if I had x minus 2 equals 0, then x would be 2. So therefore my critical value is 2. All right, now I'm going to do my sketch. Now, whether I did my sketch from the original inequality or I do my sketch from the inequality that I've got my CVs from, I'm going to get the exact same answer, provided I know what I'm doing with my sketch. What's going to happen is these CVs are going onto my diagram as 0 and 2. So those are my CVs, those are my critical values. That's where it's going to cut the x-axis. So now I'm going to draw my parabola or my quadratic function, and I need to know, is it a happy face or is it a sad face? So what I'm going to do is, if I look over here, if I were to take that 2x and multiply it back into that bracket, I'd have 2x squared, a positive 2x squared, which would give me a smiley face parabola. So I'm going to have a smiley face parabola. All right, there's my smiley face. If we read our inequality, it says 2x into x minus 2 must be greater than 0. So that must be positive. Now, positive is above, negative is below. So that means, where is this smiley face or this parabola? Above. It's above from that 0 and from that 2. So it's going to be above all the way over there, which means it's going to be above from where x is 0 in that direction, so in the negative direction, from where x is 2 going in a positive direction. So therefore, x, it must be less than 0, or x must be greater than positive 2. Now, it's not less than or greater than and equal to, because in the original question, the inequality sign doesn't have an equal to. Now, this question finished. However, I just want to touch base on this particular question if the inequality sign was the other way around. So this is just a side note. So maybe I'm just going to draw it into a little block over here. All right, and if I had my exact same smiley face, here is 0, here is 2, so there's my parabola, all right? But if I had 2x into x minus 2, and instead of it being greater than 0, I'm going to make it smaller than 0, just as a little note. All right, so if I had it being smaller than 0, then that would mean, where is it negative? And where is this graph below the line? It's below the line between 0 and 2. So it would actually be this over here. So this whole part is underneath or below. So therefore, I would have x being between 0 and 2. So you can actually see the difference between these two answers. So over here would be if it was above, and over here would be if it was below. Next question, I have x squared greater than 3 into x plus 6. Now this is an inequality question, so I look at my inequality, which means that I'm going to have a sketch and I'm going to have CVs or critical values. What I'm going to do is, I see that it's not only an inequality, it's a quadratic inequality, which means that I'm going to take everything to one side, put a 0 on the other side, then I'm going to factorize fully. All right, so I'm going to see that I have the 3 into x plus 6. So I'm going to start by just removing that bracket. So I have x squared being greater than 3 times x, which is 3x, 3 times 6, which is 18. Now I'm going to take everything to the one side. So I'm going to leave the x squared on the left because it's positive. So the x squared, the 3x when it goes across becomes negative 3x. The 18 when it goes across becomes negative 18. And that will be greater than 0. All right, so now what I'm going to do is I'm going to factorize fully. So I look at my third term. My third term is a negative 18, so that tells me that the signs are going to be different and that I'm subtracting the factors of 18 to give me my middle term, which is a 3. What are the factors of 18? 1 and 18, 2 and 9, 3 and 6. Which of those factors, when subtracted from each other, give me a 3? That's the 3 and the 6. So I'm going to have 2 brackets and it's going to be greater than 0. The signs inside the bracket are going to be different. One will be a plus, one will be a minus. How do I know that? Because my third term was negative. The x squared when factorized becomes x and x. And now I just need to decide which of the 3 and the 6 get the negative. I look at my middle term. My middle term is negative, which means the bigger factor gets the middle term sign. So the 6 gets the negative, the 3 gets the positive. Now at this point in an equality, in an equation, what I would do is I would say, therefore, x is equal to -3 or x is equal to +6. But it's an inequality. So that means that I need my CVs, my critical values. And my critical values I still get from within the brackets. So my CVs are -3 and +6. Now I'm going to have my sketch. And my sketch will have those two values on it. It will have a -3 and a +6. I need to decide whether I'm making a happy face or whether I'm making a sad face, and that is dependent on the A value. So if I look here, my A value is a +1, so that means that I'm drawing a happy face. There's my happy face. All right. And x plus 3, x minus 6 is greater than 0. So greater than 0 is positive, positive is above, negative is below. So this is above. So where is this parabola above? It's above at the -3 and it's above at the 6. So where will it be above? It will continue to be above when x is less than -3 or when x is greater than +6. So therefore, x needs to be less than -3 or x needs to be greater than +6. The next question is solving for x still, but it's 2 to the power of 3x plus 1 plus 2 to the power of 3x is equal to 12. All right, now we have an exponential equation. Now, an exponential equation, what we do is we would make the bases the same, then you drop the bases and you equate the exponents. However, this particular one has a plus in between, so that brings me to our step of factorize to simplify. So we are going to FTS, factorize to simplify. So what does that mean? That means that I want to take this 2 to the power of 3x plus 1 and I'm going to break it up. So this is 2 to the power of 3x multiplied with 2 to the power of 1 plus 2 to the power of 3x equal to 12. All right, now we can clearly see that we have 2 to the power of 3x on that side of the plus sign, and we have 2 to the power of 3x on that side of the plus sign. So that means that I have a common of 2 to the power of 3x, which I can then take out. Now, if you can imagine, don't scribble on yours because you don't have an undo button like I do, but I'm going to take out those 2 to the power of 3x's. All right, so when I take 2 to the power of 3x out of this first term, I'm left with a 2 or a 2 to the power of 1 plus, so I'm just going to highlight this plus being this plus over here. And when I take 2 to the power of 3x out of 2 to the power of 3x, it doesn't fall away, because if it were to fall away, if I were to go backwards and try to remultiply into that bracket, I wouldn't be able to, because there'd only be one term inside of the bracket instead of the 2 that's needed. So when I take 2 to the power of 3x out of 2 to the power of 3x, I'm left with a 1, and that is equal to 12. So now I have 2 to the power of 3x multiplied with 3 equal to 12. Now I can get rid of this 3 by dividing both sides by 3. So now I'm going to divide both of the sides by the 3 so that I can get rid of it, which means that I'll have 2 to the power of 3x equal to 12 divided by 3, which is 4. Now I'm going to solve this like a normal exponential equation, make the bases the same, drop the bases, and equate the exponents. So 2 to the power of 3x is equal to 4 becomes 2 squared. So this 4 became this 2 squared. Now that the bases are the same, I can now drop the bases. So I can say that 3x equate the exponents. 3x is equal to 2. Divide both sides by 3 to isolate the x. Therefore, x is equal to 2 over 3. Next question. If I have the square root of x minus 1 plus 3 equal to x minus 4. My first step with solving a surd equation is to isolate the surd. So that means get the surd all by itself on one of the sides of the equal sign. So I'm going to isolate it by getting rid of that plus 3. So that means that I'll have the square root of x minus 1 equal to x. The minus 4 stays there. The positive 3 becomes negative 3. Minus 4 minus 3, which is negative 7. Now what I have to do is I have to get rid of that surd. So in order to get rid of that surd, I'm going to square, because the opposite of square root is to square. So I'm going to square that so that the square and the square root cancels. But what I do to the one side, I do to the other side. There's a binomial on the other side, so I'm going to put the whole thing into brackets and I'm going to square it. So the square root of x minus 1 all squared becomes x minus 1. And that is equal to x minus 7 all squared, which is x squared minus 14x plus 49. Please remember that when you're squaring out a binomial, it's going to result in a trinomial answer, 3 terms in your answer. So now I just have a quadratic equation to solve. How do I solve a quadratic equation? I take everything to the one side, I make it equal to 0, I factorize fully, I make each factor equal to 0. So I'm going to have 0 is equal to x squared, this minus 14x, and this x, the x when it goes across becomes a negative x minus 14x minus another x is negative 15x. And then this positive 49 and this negative 1, the negative 1 becomes a positive 1, 49 plus 1 is 50. So 0 is equal to, now I'm going to factorize this. I look at my third term. My third term is a positive 50, which tells me that both the signs are going to be the same. What are they going to be? I look at my middle term. My middle term is negative, which means that both the signs are going to be negative. Then I'm going to take the factors of 50 that when added together give me my 15. What are the factors of 50? 1 and 50, 2 and 25, 5 and 10. Which of those factors when added together give me 15, the 5 and the 10? So now I factorize the x squared, it becomes x, and 50 becomes 5 and 10. Everything to one side, make it equal to 0, factorize fully, make each factor equal to 0. So therefore, x is equal to 5 or x is equal to 10. So when we're working with a surd equation, we need to isolate the surd and then we solve for x. Now once we solve for x and we've got to this answer, we have to check our answer. That was dramatic, wasn't it? Yeah. Check your answer. So when we check our answer, we are going to substitute the 5 into left-hand side, right-hand side, substitute the 10 into left-hand side, right-hand side. What you'll see is that the 5 doesn't work, which means that you have to cancel out the 5 as an answer and you choose the 10 as an answer instead. Remember, in case you don't remember how to check your answer, you substitute the 5 into the left-hand side, you substitute the 5 into the right-hand side of the equation that you were given, and you check if the answers are the same. If at the end the answers aren't the same, then that answer is not applicable. Do the same thing with the 10. So this third equation, I have the square root of x minus 1 plus 3 equal to x. So I have a surd. So step number 1, isolate your surd. So to isolate the surd, I'm going to have x minus 1 equal to, keep the x on the right-hand side, the positive 3 when it goes across now becomes negative 3. To get rid of this square root, I'm going to square so that the square root cancels with the square. What I do to the one side, I'm going to do to the other side, so I'm going to square the other side too. So now I have x minus 1 equal to, when I square this out, I'm left with x squared minus 6x plus 9. So this is a quadratic equation, so I'm going to take everything to one side, I'm going to make it equal to 0, I'm going to factorize fully, and then I'm going to make each factor equal to 0. So now I'm going to have 0 is equal to x squared, the minus 6x stays the same, the x when it goes across becomes a minus x, so that's minus 6x minus x, which is minus 7x. Positive 9 stays the same. The negative 1 becomes a positive 1. Positive 9 plus 1 is 10. So 0 is equal to, so I'm going to factorize this trinomial. by looking at my third term. My third term is a positive, which tells me that the signs are going to be the same. What are they going to be? They're both going to be the middle term sign, which is a negative. It also tells me that I'm adding the factors of 10 to give me my middle term, which is a 7. The factors of 10 are 1 and 10, and 2 and 5. Which of those factors, when added together, give me 7, the 2, and the 5? So the x squared factorized becomes x and x, 2 and 5. So now I'm going to make each factor equal to 0, so therefore x is equal to 2 or x is equal to 5. When I substitute the 2 and the 5 in, I'll see that only the 5 satisfies that, which means that the 2 is a not applicable solution, so I have to cancel it out as an option. The next question says solve for x and y simultaneously. So now we have two equations. Now the first point of simultaneous equations is that there needs to be an isolated variable. Now in this case, once I've written it out, I can actually see that we do have an isolated variable already. So what I'm going to do is I'm just going to label my equations. So I have equation number 1 and I have equation number 2. So now, because for equation number 2 there's already an isolated variable, I'm just going to substitute that straight into my equation number 1. So I'm going to say substitute equation 2 into equation 1. So in equation number 2, where I see that y, I'm going to substitute this whole equation in. So 3x, keep the minus because it's outside. In brackets, I'm going to substitute in negative x squared plus 2x plus 8. All right, so now I've just substituted that in place of the y. And now I'm going to carry down what's left, which is plus 2 is equal to 0. Now I'm going to solve for that x. So I'll have 3x. That negative sign is going to jump into the bracket. So a negative and a negative gives me a positive x squared minus 2x minus 8. Carry down my plus 2. That's not affected by the negative, is equal to 0. All right, so this is a quadratic equation. How do I know that it's a quadratic equation? Because my degree is a 2. So I'm going to, everything to one side, make it equal to 0, factorize fully. So everything is on one side, it's already equal to 0, which means I'm just going to factorize fully. So I have x squared, then I have minus 2x plus 3x. I have this 3x and this minus 2x, which gives me positive x, minus 8 plus 2, which is negative 6, is equal to 0. So now I'm just going to factorize this. I look at my last term. My last term is negative 6, which tells me that the signs are going to be different. One will be a plus, one will be a minus, and that I'm subtracting the factors of 6 to give me my middle term, which is a 1. What are the factors of 6? 1 and 6, and 2 and 3. Which of those, when subtracted, will give me a 1, 2, and 3? Which means that I have an x in both brackets, and then I have a 2 and I have a 3, so now I need to decide which one is which one gets the plus, which one gets the minus. I look at my middle term is plus, which means the bigger factor gets the middle term sign, so in this case it's the 3, so the 3 will get the plus, the 2 will get the minus. Therefore, x is equal to negative 3, or x is equal to positive 2. So now I have two x values and I want to get two corresponding y values. So I like to go into the easier equation, the one where you already have your isolated variable. However, if you went into either of the equations, you'll get the same answer because we've equated the equations. So therefore, y is equal to negative 3 squared plus 2 times negative 3 plus 8, or y is equal to negative 2 squared plus 2 times 2 plus 8. So I therefore have solutions of y being negative 7 or y being 8. So we had an x value of negative 3. We've just determined that the corresponding y value is negative 7. and we have an x value of positive 2, and the corresponding y value is 8. The next question is my simultaneous equation question. 2y plus x equals 1, and x squared plus y squared plus 3xy plus y equals 0. So I'm going to start by writing out my two equations, and then I'm going to label them. So I have equation number 1, and I have equation number 2. Now with simultaneous equations, we have to have a subject of the formula. So I look at my two equations and I decide what I'm going to make the subject of the formula. So we can see that in equation 1, we've got an x, which will be easier to make the subject of the formula. So I'm going to have x is equal to, the 1 stays the same, the 2y when it goes across becomes negative 2y. I created this from equation 1, which means that I will label this equation 1a. Now, whether you label this equation 1a or equation 3, it doesn't matter. The reason I like to label it with an a is to just remind myself which equation I used to create this new equation. So now what I'm going to do is I'm going to substitute the equation I just created. So I'm going to substitute equation 1a into the other equation, which in this case is equation number 2. So that means that in equation 2, wherever I see an x, I'm going to replace it with 1 minus 2y. So I have x squared, which means that I have 1 minus 2y squared plus y squared plus, now I have 3xy. So all I'm going to do is I'm just going to move the y in front just so that I don't forget about it, but it doesn't matter if you didn't. So I'm going to have 3y into, and then I'm going to put the x, which is 1 minus 2y plus y equals 0. All right, 1 minus 2y all squared becomes 1 minus 4y plus 4y squared plus y squared plus the 3y when it jumps into that second bracket. 3y times 1 is 3y. 3y times negative 2y is negative 6y squared plus y equal to 0. All right, now I'm just going to collect my like terms. So I have 4y squared plus y squared, which is 5y squared, minus 6y squared, which is negative y squared. Then I have minus 4y plus 3y, which is negative y, plus another y, it's going to cancel out. And then I have my constant there of positive 1 equal to 0. All right, now this is going to be the difference of two squares, but it's currently, I could either just swap the 1 and the y squared around, or I could divide everything by a negative 1. Negative y squared divided by negative 1 is y squared. Positive 1 divided by negative 1 is negative 1, equal to 0 divided by negative 1 is still 0. Now I have the difference of two squares, which means that I'm going to have two brackets, one with a plus, one with a minus. The y squared gets factored into y and y, the 1 as 1 and 1. Therefore, y is equal to negative 1, or y is equal to positive 1. Now I have two y values, so to get the two x values, I'm just going to substitute these y values into my equation. Now remember, I like to go into the equation with the subject of the formula already. So that's equation 2a. So therefore, I'm going to say that x is equal to 1 minus 2. In place of the y, I'll put the y value, which is minus 1, or x is equal to 1 minus 2 times the positive 1. So x is equal to 3, or x is equal to negative 1. What have I done? I've created the y value, which is negative 1. The corresponding x value is positive 3. And then I have y being a positive 1, and the corresponding x value is negative 1. I do hope that you've enjoyed this video and that you've taken down notes. Remember, the more you do, the better you'll be.